Hello and welcome back. If you follow the channel, you know that we recently went through a pile of boxes that had been accumulating while we were so busy with our Apollo Comms equipment restoration. In there were many treasures, including an IBM Tester Blinken Lights machine and a Silent 703 terminal. We'll come back to these in future episodes. But for now, we are interested in the last box, a piece of HP test gear that looks like a cute mini PC. This is an RS-232 tester, the third generation of them. It has 5 microprocessors in it from every company. I think there is an Intel, a Motorola, a 6502. It's incredible. There's just 5 macros in it.
It's so cute with a little keyboard.
So I bought it for the cuteness factor. So yes, quite cute, but also useful. This is actually my good unit. This is the one I want to repair with the one I just unboxed. And this one, I call it good because it came with all the fixings. It's complete. It has the Y cable. And basically this thing, its main usage would be as a snuffer. So that's why you have the Y cable. This would go like so over here, and on one side you have the DTE or the data terminal equipment, and the other side you have the DCE, the data communication equipment, and you basically intercept the traffic between the two. You can also see that it's super extra convenient. It has a patch panel, so if you have a plug that's wired differently, you can open up the little contacts, and then you can jumper them whichever way you want. So it's basically a complete flexibility with your connections. This machine harks back to the time where serial was used to make networks instead of Ethernet. So it's basically a pre-Ethernet network debugging machine. It also has ports for the 449, RS449, and even V.35, which I think goes up to a mile. Go, beeps of joy, HP 4957, and I'll just attach it to my computer port. Here we go. And right away it gives you some indication, so that's really neat. It tells you what's on your lines, and I see that RTS and DTR are not on, which means that on the computer side I must not be on. Serial port. Yeah, how come 3? How come I'm not seeing anything? Oh, there you go. It turned on. Alright, so we are cooking. I'm going to switch that one to 300 baud, and let's see if it can find it. So auto configure. Let me clean that up. So it's now on auto config, and I'm going to just type some random characters and see if it can recognize what that protocol is. So I'm typing. You see the data coming through. Oh, it got it. It's 300 baud, asynchronous. Yep, there we go. And now it should recognize stuff. Yeah, we have characters. Some of them are blinking. It thinks it has parity errors. Ooh, let's see if I can do something about this camera. It's blinking like crazy. Okay, I'm back at 30 frames per second. Works better. Probably didn't get parity right, but it got the speed correct. So setup. Character, yeah, I'm not ASCII 7, I'm ASCII 8. ASCII 8. Parity odd. Yeah, so it can't. So it was ASCII 7 parity odd, but it's ASCII 8 parity none, which has the same number of bits, so there is no way it can tell. And we should be fine now. While we're on the setup screen, let's note that this machine knows about every serial protocol known to man, so it can of course do the UART one we're familiar with, but the better one that were used at the time for networking, HDLC, SDLC, the IBM version, X.25, BySync, also IBM. And on the character sets, I have ASCII X, ASCII 7, IPSIDIC if I want to talk IBM, and I have even Bodo if I want to talk to the teletype. So a very broad range of possibility. Run line monitor. Yeah, okay, it has the right characters. And it's pretty neat, right? You can see all the characters, including hexadecimal value. So now I'm in hexadecimals and it shows me the X characters. So Control C is 03, Control G should be 07. The line that's dark, that's what's sent from the DTE. The line that's highlighted is what's sent in the other direction from the DCE. And you'll see that I'm not sending anything from the keyboard because I'm supposed to be on the Y cable and I'm supposed to see traffic going both directions, so this is not connected. So there is a way I can set it something. So if I go exit and get into the simulator menu, I can simulate myself now and act as a DC. So the other side of the terminal, the computer side, and here I wrote a little program that turns all the control lines on to make sure everything works, and then it's going to send the quick brown fox message and loop over that. So now if I do run menu simulate, it's going to send the quick brown fox message to the other side. Here we go. And then now, if I type here, you see my stuff coming back over here in the black line. So we go both directions. But the best way to do that is to use the VT100 terminal emulation that's in this machine. And this is basically a fully fledged VT100 terminal, except is much more portable and much nicer. So for those not in the know, the VT100 is the Digital Equipment Iconic terminal from 1978. It was much cheaper than an IBM terminal, used simple serial protocol instead of IBM's proprietary control scheme, and most importantly implemented a full set of easy-to-use escape sequences to control the cursor position and highlighting. These became the de facto standard for terminals and is still the basic terminal emulation one would expect when using text-based applications like in Linux, for example. So VT100 terminal emulation is one of the most important things I want to use this for, but sadly it's the only thing that does not work on this machine. So what happens when I switch to the VT100 emulation is that the video goes to higher resolution to support the 80 characters per line, and somehow in this resolution the characters are all messed up to the point of being unreadable. And to make matters worse, the 4957 is a 1992 machine. That's about the time when HP stopped making schematics and service information available. And not only does it not have published schematics, but it is full of Xilinx FPGAs instead of standard TTL. Reverse engineering it would be very difficult. Hence the idea to buy a cheap parts machine and attempt a board swap. And so the default is with the video generator, which is not documented. And this one's not going to come up. So we're not going to know it's deed.
That's unfortunate.
Yeah, well, it's a parts machine, right? So we just opened our 4957A, and it's a later iteration of the 4951. Another historical side note here, this line started with the 4159A in 1985, then followed by the faster 4952 in 1987 or thereabouts. The 51 and 52 are implemented with more or less standard logic and several daughter cards, and the 51 is lightly documented. but both lack the 80 character per line VT100 implementation, and the interface patch panel is an outside bulky panel shown sitting on top of the instrument here, which is why I much prefer the 57. But the 57 is from 1992, the time at which HP turned semi-evil and stopped releasing service information, bringing us to the current sad state, depriving us of the right to repair. And to make things worse, all the electronics have been condensed into Xilinx FPGAs, which would be very difficult to reverse engineer. So this is the nicer instrument, but also the harder one to repair. And Eric, you spotted all the microprocessor already. 68,000.
8188.
Intel, Motorola.
Z80, looks like another Z80.
Two Z80s. There are 5, so we have 4, so we're missing 1. What the heck, HP? Why do you need 5 microprocessor to do one thing? Okay, it doesn't even turn on, so power supply, I guess. So it looks pretty self-explanatory. Input fuse, input, which is good. Input filtering capacitor, diode bridge, main switching transistor, control section for the main switching transistor, transformer. On the other end of the transformer, the 3 double diodes for the 3 voltages. Those are the filtering capacitors. That's the feedback from the low voltage side, and opto-isolators across the line of demarcation between the high voltage side and low voltage side.
So is this on?
Not yet.
Not yet.
Okay.
That's minus S plus.
My reaction was the same as yours.
Mark seemed very
Minus
casual.
plus DC 300 volts, I suppose.
Yep, probably. Go ahead.
And 2, you're on it. 163 volts. Okay, it's
So
getting
we're
something.
DC volts.
Okay, so that side.
It's not draining very quickly.
But we have a good capacitor, right? So that section works. Do you want me to bring the scope?
Wait a minute. It's got a bad solder joint on the connector.
Oh, you can see it?
Yeah. But if you look right there, you can see there's little cracks all the way around the pin.
Yeah. You want to see if we have something at the output?
Yes.
No
Nothing.
say. Oh!
You fixed it.
Look at that.
6.8 volts.
That is interesting.
Do you think it's a bad solder joint and you just poked it into...
I think so.
Well,
So
and I
we
see
might be missing
there's
a rail.
no LEDs lit over here, so there's no internal errors.
And come to think of
Your
it-
screen is lit up very nicely. It says 4957. You should get a shot of the screen.
Alright, and the screen's not that bad. Okay, just let's resolder that thing quickly and then see if we can get something out of it. So we resoldered the connector, but this was apparently only part of the issue because the unit would still not start reliably. So little update after the power supply started for a few times, then it started not to start anymore. And so I changed that capacitor, which is the start capacitor next to the big resistor. So switch power supplies, they need some voltage to power the ICs to start with. The cap here is under famous stress. And sure enough, I replaced it, and this one looks super bad. There you go. So leaky. A dead cap. So now it starts every time. So we repaired the power supply already, and the other thing you have to do is get the battery fixed, because there's a nickel cadmium battery that acts as the backup for the RAM, and it's 4 of those little 1/3 AA. They are wired a little bit weirdly. They are parallel here, and they're stuck this way, so it's a serial parallel thing. Okay, it's not pretty, but I made an okay replica. Unfortunately, I don't have spot welding, so I have to solder it, which is not ideal. I even picked off the pins from here and resolder them back here. So that should do a good replacement. There you go. So that was it. That was a bad little cap in the power supply. Alright, I think it's healed. Reset mass storage, load applications, this one. Load application, VT100. Execute. Aha! That should be high resolution. It is, it works! But this one just works! Okay, well, we don't have to repair the other one. This one's going to become our main machine. So here's my other one. So we can make a battle of the 4957s. Where are you? VT100. This is what I just did. Okay, you'd have to hit it twice. Execute. Okay. See that? You have an interesting fault for you.
Oh. That was pretty scrambled.
Oh, I'm wondering if this... Oh, wait a second. So this one didn't switch to higher resolution. So this is what happened. This has 40 columns. This one has the 80 columns. Oh, they are not the same. Look, so this one stayed into the VT100 whatever low number of columns, and this one has...
Is there a config option for that maybe?
This one has a double resolution, but it's not behaving properly. So I still didn't get exactly what I wanted. So you do an F, it works, and then you do a G, it will mess the F before it.
It's actually overprinting.
Yes.
So if I do F and then I do a G, it's overprinting the G on top of the F.
Yeah, so it's going to the wrong RAM address or something.
Keyboard.
So dang, neither are perfect. And in this one they did something silly, right, to double the resolution.
Mm-hmm.
And another viewer told me he had the exact same fault on his machine. So dang, how come one can do it and the
It's
other one?
going to the previous line. The problem is that we see a character that's overstriking another character, and that's not normally possible in a text frame buffer. Like you can't do it. But here, I think what they do is they're pulling in 2 characters for every single 40 column character cell. So in other words, there are 2 separate pixel streams coming in, both faking a 40 column screen, and then they mux between the 2 to turn them into 80 column.
And I really wonder why one machine has it and the other machine doesn't have
So
it.
it would be a
Is this just a firmware trick?
Is this does this have an older version of the firmware? Do you know which version?
This one is the copyright 93. This one is copyright 91. So is that something they added later?
We could compare the logic on the boards and see if they made any changes there, and then look at any programmable devices, and then presumably we could just reprogram a new set, put them into that machine, and upgrade it. I mean, it's just FPGAs, so there may be a bit stream that's different between the 2.
So we decided maybe if we can upgrade the ROMs put the ROMs from the more modern machine that has the high resolution to the older machine that has a low resolution, maybe we can upgrade the other machine to higher resolution. We're going to swap the ROMs. So give me number 1. This one. Oops. Oh, you loosen. Oh, this is so nice. It works. All done. And number
Pin 1 is all correct.
2.
Just making sure.
Yeah, I'm just trying to put them in the same orientation. Alright, see if we gain double resolution. Well, if it's not plugged in, no. Okay, yeah, it passed the initial. I saw the LED blinking come back to life. Alright, and it has the AAO2, so it's been upgraded to the 93 version. More.
Brain swap is successful.
Brain surgery successful. VT100, execute. VT100, execute. And it works! We have successfully
look at that.
gotten the high resolution transferred to the other one. So it's really from the ROMs. And this one doesn't have the software issue. Well, but then I get two machines that work, right? Because if I put the other one, which is not going to use the high resolution mode, that machine is going to work.
That's right.
Should we try that?
Okay, we are transplanted.
Okay, want to is it
I would love to. You ready?
Yep. Okay, well, LEDs went off. Good. More. Load app. VT100. Execute. More. Now I know it. Load. Execute. And now we have two machines that work. One in high resolution and one in low resolution. So, we did something. That's pretty, at least both are usable. So I don't know. And Eric, if you want to fall into a rat hole and figure out what that fault is, you're welcome to. But I think for now, if I connect that one to my the chip tester, that needs RS-230 to make it my chip tester, and the other one I might make it my cute terminal. And here you go. For a moment I thought I would end up with two bad machines, but a simple ROM transplant between the two gave me two good machines. And I looked everywhere, there is no mention of a 4957 having the lower resolution VT100 emulation anywhere, although this was the resolution supported by the previous 4952. So my best guess is that my parts machine was an early sales demo with pre-production firmware, which jives well with the 1991 date on the firmware. Well, it turned out to be good karma for us and allowed us to end up with two good machines. Perfect, we'll put them to good use in the next episodes. See you then!